Right, the noble gases. This is quite a short little section, but they're well worth a mention. Okay, they do stand out. Remember, they weren't really found for a long time because they don't react, so you couldn't actually find them in compounds, and also because they're in such small amounts. So, for example, our friend helium, which we're so used to nowadays, well, it was discovered on the sun before it was discovered on the earth, which is where it got its name. Helios. I think it's the Greek for sun. Maybe it's the sun god. Who knows? Google it. So, helium. And what are the other ones? Neon, argon, krypton, xenon, radon. Okay? And they're in very small amounts on the earth. I recommend this book by Sam Keen. This is a quote from the book. He raves about the noble gases. So you can read through that. The book's well worth a read. It's called The Disappearing Spoon. Excellent book. Anyway, back to business. They exist in the atmosphere in trace amounts. Very, very small amounts. So characteristics, they are colorless, monatomic. Monatomic because they don't form molecules. They don't need to because they've already got their perfect electronic structures, full outer shell, electronic nirvana. Okay? And they are gaseous non-metals. Obviously non-metals, there's no metallic character. And gaseous because there's very, very weak forces between the atoms. So it doesn't take a lot of energy to cause them to initially melt and then to vaporize, to form gases. You can look up the melting and boiling points. Unreactive, they've got a full outer shell. They've made it electronically. The density increases down the group. The atoms become bigger, but also the mass becomes much bigger. So the mass obviously increases. And when you divide the mass by the volume, you get more dense atoms. Okay? The uses of the gases will depend on their unreactivity, their low density, in the case of helium, and how they behave when they come into contact with electricity. Let's have a little look at some of the uses. Air balloons. Initially, they tried using hydrogen for these zeppelins, but there was an enormous disaster, wasn't there? I think it was in 1912? When one of these big zeppelins caught fire, the hydrogen burned. So they tried helium, and helium does work. Obviously, there's a very small motor and a very small, what do they call this underneath? A basket underneath. And these things are prone to strong winds. So really the prevailing wind direction here obviously has a big part to play in their practicalities. But anyway, helium can be used in airships. The noble gases can be used in what they call them neon lamps, don't they? But if you put the gases inside a sealed gas tube and you pass an electric current through it, then they glow different colors. Argon is used in light bulbs, essentially because the tungsten filament, which glows, it would react with any oxygen present. So you need an inert atmosphere so that this tungsten filament doesn't react. So they fill these, or they partially fill them with argon, potentially with other gases too. But you don't want any oxygen in here. Why? Because it would react with the tungsten filament. Lasers use krypton, and I'm not a big expert on lasers, but obviously you've got electrons being excited and all kinds of wonderful things going on, and light being emitted at high energy. Okay, but it uses, typically krypton. I don't know if they use other ones. In balloons, we use helium. There's a limit to the amount of helium on the Earth, obviously, because helium tends to escape the Earth because it's so small. So the price of helium has gone up tremendously, and it's quite a rare commodity. So these are quite expensive things. Helium is also used for scuba diving. You might want to look into that. Lights, xenon lights on cars are the typically bluey white lights, very powerful lights you get in cars. This is supposed to be somebody welding metal. So when you weld metal, you get very high temperatures and you fuse the metal together. You melt it and you stick the metal together. But you need to do this in an atmosphere that doesn't have any oxygen. So you can use argon as an atmosphere so that the weld is much stronger. Okay, right, you've got some questions on those pages, and you've also got the end of unit practice questions on the pages indicated. You can start to review this unit on the periodic table.